Hey everybody, it's Tyler here at the World Championships, checking the 195 CyberKnights. We've been an absolutely phenomenal season. 2 event wins, plus finalists at the DCMP as well too, and looking absolutely stellar here at the World Championships. Take a look at what 195 has to offer on here. I love the overall design as we go through. Of course, we'll be talking about all the components and features that go into this robot. Some great programming stuff as well, but I really like how they are approaching scoring both the cubes and the cones. Let's learn more about 195 and their charged up robot coming up here on Behind the Bumpers.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. AndyMark has parts and products designed specifically for First Robotics competition and First Tech Challenge teams. Many AndyMark staff are First alumni, mentors, and event volunteers. Visit andymark.com for all your educational robotics needs. Kettering University has over 25 pre-college camps and learning experiences available, from computer science and engineering to inspiring future women engineers, leadership development, and first-based camps for first graders to graduating high school seniors. Magna and GM-sponsored camp fee scholarships are available. Email ctaylor@kettering.edu for more information.
Caitlin, let's start off talking about some of the manufacturing design process for 195. You know, 195's been making awesome robots for a long time here. Not only is it aesthetically pleasing, but very functional as well. So talk to me about some of your bases for it as we start to go into your robot.
Okay, for our drive base, this is the first year we're doing Swerve Drive. We bought these Swerve Drives from Swerve Drive Specialties. They're MK4 modules, and they're the L3 modules. For our drive base, we also have a steel ballast on the backside of our drive base to counteract the battery weight. This makes our center of gravity more in the middle, so it's less tippy.
How much does your ballast weigh in a robot?
It's around 4 pounds.
Okay, that's not much actually, so that's kind of cool design-wise. Did you add that in afterwards from when the season started?
Yes.
Okay. I mean, they only have to do 4 pounds. I've been talking to other teams like we had to add 35 pounds to make it work or something. I think that's pretty well designed. All right, so Alyssa, talk to us about other parts on your robot.
So the next major part of our robot is what we call the super arm. It's this entire main structure here. So there's 3 stages in our super arm. We have the main stage, which is made out of carbon fiber. We initially made this main stage out of 50 thousandths wall aluminum. We found that it was a little bit heavy and brought our center of gravity up a little bit higher than what we wanted. So we switched over to carbon fiber. We eliminated about 4 pounds off this top part of the robot. Keeps our center of gravity sitting about right here. The next part is we have our second stage, which is right here, and this part extends outward. So that kind of increases our range of motion there. And then we have the third stage, which is pneumatically actuated with a cylinder on the inside of that third stage, which allows us to reach those higher nodes. So all 3 stages are able to rotate. Increasing our range of motion allows us to really create a lot more fluidity between all of our positions, and helps keep our balance while we're playing the game.
You know, we see a lot of different types of arms here in charged up for things. This overall design, how was this like the best fit for 195? When you look at like all the different designs we've seen, your robot's been doing so well. How did you end up coming up with this final design for your robot?
Well, we ended up deciding to kind of do a robot that fed through itself because it allowed us to score and pick up pieces from both sides. So it is bidirectional. We are able to do that using some odometry in our programming, which Tyler will talk about in a little bit. But no matter which way we're facing, we can pick up and score pieces. And it also, by feeding through our robot, it helps keep our center of gravity lower once again, instead of going over the top of our robot, helps maintain that stability.
And then from a game strategy standpoint, when you're looking at going on the field, where's kind of like where do you prefer to pick up from, and from your cycle times, what's getting you the quickest cycle times on the field?
Quickest cycle times, we like to pick up from the shelf, pick up from either shelf. We can pick up from the ground, although we do prefer one of the shelves. We are faster with cones, but we can do both pieces, both very quickly.
Awesome. Sarah, let's talk about some of the electrical on this robot as well, too. You have a very clean design for this. I'd love to hear. I know we were talking earlier, you do a little bit of color coding for it.
Yes.
So talk to me about what makes it special on 195.
So we actually color code all of our swerve modules, and this allows us to have very quick changes if we need to change a swerve module. We actually have changed them in about 3 to 5 minutes, and we actually had to change 2 in one match, in between 2 matches once, and we were able to because of the color coding and how quick and easy it is to move in and out.
As we start the wrap on this robot, Tyler, we're going to talk about more of the programming side of things, showing off some arm positional control, talking about your autos as well, too. I mean, this robot, obviously, mechanically it's gorgeous, but there's a lot that goes into the program as well to make it what it is. So talk to me more about it.
Yeah, sure. So to start, for our arm control, we have preset positions for for each part of the arm. So we can individually control the base and the upper arm as well as the extension. So we have a state machine that allows us to set all those positions, and then the driver just has to hit one button to go to any of the states. And we also have some transition states to allow it to not collide within the robot, so that and also the grid, so that we're not hitting the grid. And this just allows for smooth scoring and very quick and efficient. So to start, for creating our paths, we have a path planner that we can plot the points on the field, and then we have the list of points which we save into a JSON file. Then this JSON file we pass to the robot, and that is combined with a Python file which has all of the arm positions. So going back to the state machine, it's just simply one line of code that says the arm position, and then we can also give it like a wrist position and also which side of the robot we want to score on. So in this all combines into our auto, along with our trajectory follower, which is mostly custom made and is accurate, so that we are getting the same trajectory every time.
You mentioned Path Planner before. Are you doing a custom pathing software as well?
Yeah, so we created our own path planner so it fits to what we want, as well as it creates a GIF of the trajectories for the auto, so that the drivers know exactly which one they're selecting before the match.
Well, 195 CyberKnights, an incredible machine, and congratulations on your success so far this year. I know we're looking for big things here at the World Championship, so we wish you the best. Can't wait to see how you do, and good luck the rest of the way.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. AndyMark is your one-stop shop for all your educational robotics needs. From mechanical, electrical, tools, and hardware, AndyMark has over 200 years of first-team experience and offers high-quality and affordable solutions for the robotics mobility and competition markets. Head on over to andymark.com to get started. Kettering University has over 25 pre-college camps and learning experiences available, from computer science and engineering to inspiring future women engineers, leadership development, and first-based camps for first graders to graduating high school seniors. Magna and GM-sponsored camp fee scholarships are available. Email ctaylor@kettering.edu for more information. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.